Actually, and this graphic that they used to show the birth of the moon, I've seen it appear in other programs since, so it's a graphic so good that it's used it multiple times. But it really does show the birth of the moon. It was a cataclysmic collision, something the size of Mars colliding with the early Earth and forming the moon that we know today. But of course it wasn't the moon that we know today. It was 5 times closer to us, and so it really must have been quite magnificent in the sky. But here, of course, is the moon that we know today. So it's moved further and further away, and we'll talk about that sort of travelling of the moon, the fact that it is moving further away, all the implications of that. But the moon is sort of a very familiar face in the night sky. And one of the things is, if we look at it a little closer, we see all the craters on pot marks all over the surface. And these are very important, because this is another way that the moon is protecting us here on Earth. This is another way that it is making a real difference to us. Because it acts as sort of a gravitational well. And so asteroids and debris that might otherwise crash into Earth often crash into the moon because they're gravitationally attracted to the moon. And this, I think, might be quite responsible for actually having the diversity of life here on our planet. There have been a number of asteroid strikes on Earth, and this is Barringer Crater in Arizona. And in that clip I showed you just previously, I was flying over it in a helicopter, which was really good fun, but a little frightening, but really good fun. So we have impact craters like this, and something much larger than this. This impact crater is about 1 kilometre in diameter, and the asteroid that caused it was only about 15 metres in diameter, so it causes a lot of damage. Now, the extinction of the dinosaurs is thought to be caused by an impact like this, but something much, much, much bigger. And so if the moon is deflecting some of those impacts, it means that I've had more of an opportunity to flourish here on planet Earth. So again, this is a way that the moon is protecting us. But this whole experience was really quite fun, because we went to Barringer Crater, and we went up in a helicopter. And it was interesting because the director said to me, okay, helicopters are incredibly expensive, so I hope you know your lines. So making me relax and smooth here, all in one. And so we went up, and I started trying to do the lines, and there was just too much noise in my headphones, and I kept on forgetting them. So what we eventually had to do is turn the headphones off, and then it all went perfectly. And then they took some shots of me, sort of leaning out of the helicopter, sort of looking at the crater. And the cameraman said, don't lean too far, be careful. And I thought, he's been a bit cautious. And it turned out that the seatbelt wasn't working. I didn't tell me at the time until I landed, but someone had been sitting in that seat before me, and the seatbelt kept on popping over. So he's been sort of leaning out of the helicopter, and the cameraman said, careful. So it was all quite exciting stuff. But again, another way the moon is protecting us. Sometimes people say to me that they don't believe that the moon landings happen. But my argument to that is, well, there's 2 arguments I'd like to give to that. And the first one is, what would the Russians do? The moon landings happened at the time of the space race. And if the Russians got a sniff that anything wasn't right, they would have had the Americans, they would have had to go for a battle. So that's one argument against the sort of the conspiracy theory that the moon landings didn't happen. But another one is that we measure the distance between the Earth and the moon quite often. And we do that by sending a beam of laser light up to the moon. And so this is sort of a green laser which we ping off retroreflectors on the moon. Now, if they never landed on the moon, what's that light reflecting off? So we have retroreflectors on the moon, and so we can measure the distance between the Earth and the moon. And we've been doing this over the last 40 years, since the moon landings and since the retroreflectors were installed. And we realise the moon is getting further and further away from us, very slowly. It's at the same rate that our fingernails grow. So it's not really travelling too fast, but it is moving further and further away. And that has had an implication for us here on planet Earth. So, one of the implications is that at the moment, the moon is just the right distance away to give the perfect total eclipse of the sun. So, if you take the Earth and if you take the moon and the sun and the sun are very, very different in size. I think, you can fit a million Earths into the sun. So it's much, much bigger in volume. And if you look at although the sun is much, much bigger than the moon, it happens that the distances make them look the same size in the sky. And so when you get a total eclipse at the moment, the moon beautifully covers the total surface of the sun, as you can see an image like this. Now, this is an image actually taken by the SOHO satellite, and so we've got all sorts of different frequencies we're seeing here. So this is actually sort of visible. This is a number of different frequencies. But this is a cosmic coincidence. And to me, I just think it's magical to be alive when this is the case. So we have the magical view of a typical eclipse at the moment. But of course the moon is moving further and further away, and that will have implications for us in the future. Because as the moon moves further and further away, it changes the length of the day. And I've got a clip here to show how we can actually look in the past about how long a day length was in the past. So this is the coral that we pulled out of the water today. And if we look under the microscope, you can see very fine ridges. And we know these are formed on the lunar cycle. These are monthly bands.
Oh, so it's a bit like the rings of a tree. You can use that to date it.
That's right. And actually we can count about 65 monthly bands.
Oh, right, yes.
This is coral, which makes it just over 5 years old.
That's pretty amazing.
But some corals are even more revealing. They allow us to peer into the distant past and find out something extraordinary about the power of the moon. This is a fossil coral from the Devonian era. It's 400 million years old, but still beautifully preserved. As well as monthly growth bands, there are annual bands, and even daily bands, 1/4 of a millimetre apart.
So this coral grew about 1/4 of a millimetre every day.
That's right.
400 million years ago.
400 million years ago. And if we took the time to count up all these daily growth bands within the year, we'd find not 365 days. In fact, in this coral, there are 400 bands every year. 400 days a year.
400 bands.
So a year.
So that means that there was an extra 35 days every year.
That's right.
That's quite mind-boggling.
If there were really 400 days in the year back then, how long was each day?
If you do the sums and take the total number of hours in a year and divide by 400 days, then you come to the conclusion that in the Devonian period, when this fossil was alive, a day actually lasted 21 hours and 55 minutes. Now, I must admit, I find that really weird. The fact that in the past, a day wasn't 24 hours.
And that was one of the weirdest things I found in the program. 24 hours just seems like a natural cycle. We know that on Mars, a day lasts for 20, I think it's 25 hours. So you get an extra hour every day. But 24 hours does seem like sort of part of our blueprint, part of us. But it hasn't always been the case. And the fact that the moon is moving away from us and that the days are getting longer means that our planet is slowing down. And one of the things we did in the program is I was introduced to someone called a ball wizard. And I must admit, when someone said I was going to meet a ball wizard, I was a bit had a bit of trepidation. Who on earth and what does this chap do? But it turns out that he does amazing things with sort of baseballs. Well, actually, no, this isn't a baseball either, but it's something slightly smaller. Now, what he can do, and I'm going to make a total fool of myself on the stage here, but what he can do is he can spin a ball. Whoops! And I really can't do because I was trying to practice. He can spin a ball on his finger. Oh, okay, I'm not going to do this anymore because I'm going to hit someone. He can spin a ball on his finger and then so it processes around and he can sort of move it around. And that's just what he did with me on the program. I had to sit very still and he sort of passed his ball around me. But what he was showing is that when a ball is spinning fast, it's quite stable. And so he can move it on his finger and he can move it around. But when it starts slowing down, it starts to process and wobble. And this is the problem with the Earth. As the Earth slows down and the days get longer, the Earth, rather than sort of spinning on its axis, it might start to slow down. And if it starts slowing down and processing, weather here on planet Earth could change radically. And one of the things we explored is what would happen if eventuality, or what will happen in the future when the Earth spins down. And we started looking at places like Vegas. Now, Vegas is, hot, it's dry, it's in the desert. But if the Earth starts to process like that, what you could eventually happen is, rather than it being on its axis like this, it could actually have the poles at the equator, and then the equator at the poles. If this happened, you would have very extreme weather conditions. So what you could do is have burning hot summers, and then very, very, very cold winters. And they were exploring with NASA scientists, could life survive this? And the problem is, life can live in very, very cold conditions, and some life can live in very, very hot conditions. But you rarely get life that can live in both. And with this change of polarity, you have to have these amazing swings. And it looks unlikely that there'll be any creatures that can actually live in that sort of environment. So again, the moon is keeping us and giving us stability, but as it moves further and further away from us, there could be interesting times ahead. And this brings up the whole environmental question. And I think that's one of the things that the moon landings really gave us. When people landed on the moon, we were able to actually get a picture, an image of our planet. And it's an image of our planet that we had never seen before. We knew that our planet was round, we knew that it was in space, but seeing it, I think Carl Sagan used the term pale blue dot, seeing it in the enormity of space suddenly made us more aware of our planet. And quite a few people say that the moon landings and these pictures were responsible for sort of the burst of environmental activity. And also the ideas of things like Gaia, the sort of the Earth as an entity, Earth as an entity that needs protecting from us, but also protecting from challenges in space, asteroid strikes, things like that. So I think the moon landings and understanding of the moon gives us a new understanding of our own planet. But one of the most important things is, I think the moon is actually responsible for life here on Earth. I've got a clip here which actually shows how the tidal movement in and out of rock pools has potentially created life here.